We're going to carry on with quadratic relations, and we're going to look specifically at ones that are in the form y equals ax squared plus k. Remember, we know that anything that's got a squared in the equation, if that's our highest exponent, then that's quadratic. Today we're going to learn what the letter a and k stand for in terms of quadratics. And let's just start by talking about a. The value of a in an equation determines two things, actually. It determines the direction of opening, and it determines the shape of the parabola. Now that requires a bit more explanation. The shape of a parabola is always U-shaped, either facing up or down. So what does it mean, shape of a parabola? Well, what it means is, has it been stretched or compressed? So they're always going to be U-shaped, but maybe it's a U-shape that looks like this, or maybe it's a U-shape that looks like this. So they're both U-shaped, but the one on the right I would consider to have sort of a stretched. If we think about it, we always think of it from a vertical, like an up and down way. So from an up and down perspective, the one on the right's like it's been stretched, and the one on the left that I just drew is like someone's compressed it, pushed it down to make it look wider. All right, so that's the two functions of the a value. So we have to keep that in mind always, that a tells us two different things. So direction of opening, that was the first one. In fact, let's do a little numbering here. This is 1, this is 2, so we're doing 1 right now. If a is positive, the parabola opens upwards. Okay? So in other words, if there is a value, it's not going to say a, it'll be a number like 1, 2, 3, 4, 5, 2.1, 1/4, something like that. If it's a positive number, in other words, no negative sign in front of it, then it's going to open upwards like this one. Okay? This one has an a value of positive 1. So where did I get positive 1 from? I'm looking at the equation, and there's no number written in front of the x, but that means that we can assume that there's a 1 there. That's always implied if there's no number there. And so that's a positive 1 that's implied to be there. If the a value is negative, the parabola is reflected in the x-axis and it opens downward. So here we have a negative a value, and lo and behold, here is a parabola that's opening downwards. So I can tell, just from looking at the equation, whether a parabola is going to open up or down. The other thing was the vertical stretch, so otherwise known as the shape of the parabola. That's what we talked about above, right? As I already said, we think of the stretch as being up or down, so not side to side. I know it's tempting to think about, if something looks wider, to think about it being stretched sideways, but we want to imagine it strictly being up or down always. So that's what we mean by vertically. Imagine that your parabola is made out of a rubber band, and you're grabbing a hold of it and just stretching it in an upwards direction, or else pressing it down to make it look wider, but we're not pulling it sideways. If a is between -1 and +1, the parabola is vertically compressed. So again, that probably requires a little explanation. So another way of thinking about this is if it's a number less than 1. So ignore the negative sign. Just imagine any number less than 1. We can then throw a negative sign on later. We know what that stands for. So picture any number between 0 and 1. So it could be a half, it could be a tenth, it could be a decimal like 0.2, it could be 0.9. Anything that is between 0 and 1 is going to be compressed. That negative one in that I've highlighted is just getting that, would just mean that it opens down. So any number between 0 and 1, positive or negative, is going to be compressed. And here's an example of that right here. Again, a value, it comes in front of the x, and that is between 0 and 1. And so that would be this graph right here, the one that's highlighted in dark, in black. And the other one that you can see in the middle is, just to give you a comparison, this would be the graph of y equals x squared, as it says above. So you can see that the darker line looks like it's been stretched sideways, but again, we don't stretch things sideways, we stretch them up or down. So really what's happened is it's just been pressed downwards. In fact, it's been pressed downwards by a half. It's half as tall as it was. And we could even confirm that on a point-by-point basis. Let's just zoom in for a second and find a point that we can read. Here is, right here, this red dot I put. Think about what the y value is of that. If we go over to the scale here, that y value of that dot is 9. That's on the original graph. So if I compress that, imagine taking half of 9. Well, that would go down to about 4.5, so about halfway between these two things. And then if I go over to this graph here, to where it matches the dark graph, look, that point that's up at the top, the one that was originally at 3.9, has been compressed to half its height, to 4.5 on the darker graph. So that's what we mean by vertical compression. So we've taken the y value, kept the x value the same of that point, taken the y value and cut it in half. If a is greater than 1 or less than -1, again, kind of an awkward way to say it, but ignore the negative again for now. Just think any number that's bigger than 1, 1.1, 10, a million, 37.2, whatever. Fractions work too. Any improper fraction like 27 over 4. Anything bigger than 1 is going to be vertically stretched. And that would be, if we want an example of that, here's this one. It's got a stretch of 2. Let's do the same thing we just did for the other one. So first of all, here's the graph. The dark one is the one. Again, think about it up or down. It looks skinnier, but really what's happened is it's been stretched upwards. If we take our original graph, our light-colored one, let me just pick a point that I can read on my original graph. So let's pick this one here at 2, 4, right? And now I'm going to stretch it upwards. I'm going to double it. So there's where the 2 comes in. So double 4 is 8. If I go over to the dark line here, look at that. It lines up. So if we double all the y values on that original y equals x squared graph, we'll get the darker y equals 2x squared graph. The last thing for today is the vertical shift. The value of k determines the vertical position of the parabola. All right, so k, what does that mean? Well, it's back in this formula here, right? It's right in the title. We got y equals ax squared plus k. So we're never going to see a or k in an equation. We just have to remember them by where they are. A is always right in front of the x. K is always something that comes at the end of the equation. As you can see, it's plus or minus something at the end. What does it do? Well, it's pretty straightforward. It's just a vertical shift. In other words, it moves it up or down. So it's going to move the whole parabola up or down. If k is positive, then the value of the parabola, the vertex of the parabola moves up, and if it's negative, it's going to move down. Let's see. So here's a couple of equations. Again, the light-colored one is just the graph of y equals x squared. So the dark-colored one is y equals x squared plus 3. So they're both y equals x squared, so there's no a value change. They're the same shape, The only difference between the dark colored one and the lighter one is that we have this plus 3. Well, look what's happened. The vertex has gone from 0, 0 up to 0, 3. And in fact, every point has gone up by 3. This point here at 1, 1 has gone up to 1, 4. And this point at 2, 4 has gone up to 2, 7. Every y value is shifted up by 3. Likewise, with a negative k value, well, everything's gone down by 3. And you can confirm that for yourself, right? 0, 0 has gone to 0, negative 3, and any point you want to pick on the original one has gone down by 3. So if we want to graph parabolas, we need to know that stuff. The other thing we need to know is something called the step pattern. Step pattern is a really easy pattern that helps us graph parabolas if we have the equation. What we do is we start at the vertex. Well, there's a whole bunch of steps here, and you can read those over if you want a confirmation, but I'm just going to walk you through them. All right? So the step pattern goes like this. One, 3, 5, 7, and so on, up to infinity if we wanted to. It's odd numbers, right? Notice how it's just odd numbers. 1, 3, 5, 7. So we're counting up by odd numbers, so really easy to remember. I'm just looking at these examples. I wish we had, you know what, I'm going to add a little example, because these two examples jump right into some slightly more difficult ones. So let me just do one quick additional example here off to the side. And I'm just going to graph y equals x squared. So I'm going to draw a little grid here. And I'm going to graph y equals x squared. So I'm going to have to estimate my grid lines. All right, so this is, and I know that this one's not going to go below the x-axis, so that's why I didn't worry about those grid lines at first. But anyway, all right, so here's how I can graph something. So start by finding the vertex. All right, so the vertex is going to be, we start at 0, 0. For a basic graph, the vertex is always 0, 0. And this is a basic graph. There's no a value to stretch it or compress it. There's no k value to move it up or down, so the vertex will be at 0, 0. Now I'm going to use that step pattern, 1, 3, 5, 7. So again, assuming each of these grid lines equals 1, so going 1 to the right is moving over 1. So I'm going to go 1 to the right, and then my step pattern takes me up 1. So I'm at 1, 1. So I've gone over 1 and up 1. Then my next step is to go over 1. I always go over 1, but then I'm going to go up by 3. So from 1, I'm going to go up to 4, because counting up from 1 by 3 takes me up to 4. So I got another point here at 4. So my first step was 1. Don't really have a lot of room to write in there. My next step is up by 3. The next one I'm going to go over by 1 from here. And then I'm going to go up by 5. So what's 4 plus 5? Well, that equals 9. So here's 9. So if I go up by 9, so up by 5 till I get to 9, then I've got another point. I'll put another point there. And parabolas are symmetrical, so I just did it to the right, but it's a mirror image to the left. So if I go over 1 to the left, I'll go up 1. Then from there, I will go over 1 and I'll go up 3. And then from there, I'll go over 1 and I'll go up 5. And so I've got these 7 points that I've drawn and so forth. And I could keep going if I had more room. But if I connect those dots together, it gives me my nice U shape. That's a basic parabola using the step pattern. That's the basic step pattern. And all parabolas follow the basic step pattern. However, a values affect the step pattern. So if I were to take this, I have to consider this -3. So here's how I would graph a part here, incorporating the step pattern. I'd start at 0, 0, and there's something funny going on with this grid, isn't there? I think that for some reason there's one grid laid on top of another. So I'll say that this is the origin here. So if this is 0, 0, then I know my entire parabola has been moved up by 7 because of that. So I'm going to have to count the grid lines because it's kind of messed up. 1, 2, 3, 4, 5, 6, 7. So here's my vertex. And then from this vertex here that I just found by moving everything up 7, now looking at the a value, I know my parabola is going to open downward, so it's going to sort of go this way, right? I'm going to erase that again, but just so you, that negative sign here is going to make it go downwards, all right? So I know that that's what I can expect. And it's going to be stretched by 3. So the last part I have to worry about is this, what do I do with this 3? Well, my step pattern is normally 1, 3, 5, and so on. I'll do this underneath. This a value of 3 is going to multiply each step by 3. So the stretched step pattern is going to be 1 times 3. My first step will actually be 3. And then my next step would be 3 times 3. So my second step would be 9. And then my third step is going to be 5 times 3. And so my third step would be 15. I'm not going to have room to plot all those, but that's how this step pattern goes, because it's stretching everything out. So I'm starting at 0, 7, as I already said. I know it's opening downwards, and I'm going to use a step pattern of 3, 9, 15. So from this point here, I'm going to go over 1. It's always over 1. That never changes. So over 1, but I'll go down by 3 this time, because that was my first step. What's my next step? Well, my next one is down by 9, right? So from that point I just made, I'll go over 1 and then down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's another one. And now I've run out of room. But again, it's symmetrical. I can put this point here. I can put another point over on the left side here. And I can draw my U shape through it. And that is what this one's going to look like. Okay, so then, last example, I know this has been going on for a bit, so I'll cut it short, or I'll try to be brief anyway. Where's my vertex? Well, normally it's at 0, 0, but this 1 here, my k value of 1 is going to move it up to 0, 1. And again, I'll have to count. Well, I'll say that, whoops, I will do this in red again. So since I'll say that this is 0, 1. Again, I know the grid's a little funny, but I'll say that the spot below that is 0, 0, so that's 0, 1. If I look at the a value, that opens upward, so I know it's going to be a parabola that opens upward. I also know it's going to be sort of compressed because it's an a value between 0 and 1. That's just approximately what it looks like. I'm going to erase that and actually calculate it in a second, but that's sort of what I'm expecting. And again, if my basic step pattern is 1, 3, 5, then this one is compressed. I'm going to take all my steps and compress them by a half, because my a value is 0.5. It's a half. So what's a half of 1? Well, a half of 1 is a half, or 0.5. Then what's a half of 3? That's my next step. Well, half of that is 1.5. And then my next basic pattern step would have been 5. I'm going to take half of that. That's 2.5. And then my next one would have been 7. I'd take half of that. That's 3.5, and so on. So I might be able to get more points on this one, possibly, because it's compressed. We'll see. So anyway, I'll start at my vertex. It's opening up because the A value is positive. I'm going to go over 1 because I always go over by 1. And my first step is up by a half. So over 1 up by a half only takes me in between these two lines. Then I'm going to go over 1 again and up by 1.5. So over 1 up by 1.5 higher takes me up to here. Then the next one is up by 2.5. So I go over 1 up by 2.5, and then I go over 1 and up by 3.5, which would take me up to here. And now I've rendered a room. Again, thanks to symmetry, I can just do a mirror image on the other side. There's a whole bunch of points. I can connect those as best I can to make my U shape. And that's how we can combine the step pattern with the A value and the K value.